Okay, question 7 says using the function shown below, determine intervals where it's increasing, decreasing, or constant. So really, you're going to be reading this graph just like you were looking at like a historical timeline. Okay, the x-axis is measuring time, if you will. Okay, with the beginning always being on the left and you end over on the right. So you start at the beginning of time or way back to the left and you start reading the graph and you look for all the spots where the graph is rising, and we see that the graph rises until it gets about to this point right here, which is at -3. So from the very beginning, or from negative infinity, all the way until we got to -3, the graph was increasing. We don't care how much it increases, we just care that over this period of time, it increased. Okay. Second up, at that point, it starts to fall or it starts to decrease. So we read along the timeline until we hit the period of time where it stops falling, and that's at about +3. So in the era -3 to 3, it's decreasing. It's falling that entire time. At that point, we see that the graph starts to rise again. So we keep moving along the timeline, and we see it's rising until it gets to about right here, which is about 8.5. Okay, so from the time 3 to 8.5, it was rising again. I have to draw a union symbol so I can add another period of time where it was rising on the increasing section. Okay, but then from 8.5 until the end of the graph, as far as we can tell, it's falling. Okay, so all the way until infinity, it's falling. So we draw a union symbol on the decreasing section, say from 8.5 until infinity. For the rest of the graph, it was falling. As for the constant, there wasn't any completely flat section of the graph. So you would write none. You could write NA, not applicable. You could write just there wasn't any. And you'll get 3 points, one for each section, one for increasing, one for decreasing, and one for constant.